Sam forgot to remind me again.
That was her job this time.
So here we are recording late into the lesson because Sam blew it. Okay, we're going to get you caught up if you're listening out there on the World Wide Web. Hello, greetings from Granite Bay, California. We are talking about absolute values. And that it means how far are you away from 0 or a number. All right, so we're talking about how far am I away from a number or 0, and we said that absolute values are always positive answers, and that the only way I can get a negative answer for absolute value is if there is a negative hanging out in front of the bars. So the bars designate this whole concept of how far are you away from something. And we talked about two parts of our absolute value problems. We refer to the inside as the guts. And the guts can be positive values, and the guts can be negative values. All right. So we had talked about what absolute value means. In this particular example, it means that there are two numbers that are 5 units from 3, and we figure out what those two numbers are, and the brilliant people in here said they were 8 and -2, and that is correct. So algebraically, here's what we got. We set up x minus 3 equals 5, x minus 3 equals -5. We solve for x, and bam! We got our answer. There we go. All right, continuing on now that we're all caught up. What about absolute values of inequalities? Don't sigh. What are you sighing? So we got x minus 3 greater than 5. Now we know, maybe we don't know this. Do we know this yet? There are, with a greater than symbol, this is referred to, we refer to this as an OR problem. I think we talked about this. That's an OR problem. And when you have a less than symbol, now we could always be greater than or equal to or less than or equal to. These guys are an AND. And the reason we refer to them as OR and AND is we're going to see graphically OR problems include all of the parts that work. And the AND problems include all the overlapping parts that work. All right, but you do need to pay attention to AND and OR because it sets up a little differently in my solution. So x minus 3, there's the guts. And we want this to be a 5, but we also want it to be a -5. Now let's think real quick. Here we are in our number line. There's 0. Way out here we got 5. And then over here we have a -5. All right, so here we go. Think about this with me now. If I want to talk about numbers that are bigger than 5, what are we talking about? 6, 6, and so on and so on. 6 to infinity. All of the numbers from here over would be bigger than 5, correct? Correct. Okay, now, let's talk about absolute value, because we cannot forget that the absolute value of -5 is also 5. Which would then mean any number that is smaller than -5, which would be -6, -7, -8. So all of the dudes or chicks that way would also satisfy this condition, because an absolute value of a -6 is actually a 6, and a 6 is bigger than 5, and so it works that way. So these are what we refer to the OR problems. They go away from each other. They don't like each other. And problems, they love on each other, and they will come together. But OR problems will depart and go their separate ways. Kind of like a sad love story. All right, so here's what we do. We take the guts, and we set up the guts in our two. Hey, knock that off. We set it up. There's the positive guts. Now what it means is we leave the sign the same. And we leave the value, the constant, the same. So the sign stays greater than, the constant stays as a 5, and we solve this thing. Move the 3 over, and we get greater than 8. We also have, now here's the deal. I want you to include the word OR when it is a greater than problem. get the word or, it's technically we're not correct there. We want to make sure we put that in here. And now we set up the negative guts part of the problem. So x minus 3, but now, what do you think we do? We do two things now to make it different. We switch the sign and make it negative. You guys are brilliant. We switch the sign and we make it a negative because we talked about that everything to the left of negative 5 would actually work for this in terms of a solution. So that's why we have to switch the sign, meaning go left, and the negative 5, we're going left of negative 5. Add our 3 and we get x is less than a negative 2. So, here's my answer. Now this is the inequality answer. We'll talk about the interval answer in just a second. There's my answer in inequality form. Graphically, it looks like what I actually have up there on the right there. But in an inequality form, we would get this. I think we're going to have to move these down. There we go. So in inequality form, let's talk about, again, thinking about putting our numbers in the right format. Small number on the left, big number on the right. So if I have a x less than negative 2, yesterday we learned that if I'm less than negative 2, that meant I was going to negative infinity. And then I'm going to stop at negative 2. And do I include negative 2? I don't, because it's not or equal to, so I just use the parenthesis, or if I'm doing ID notation, I have outside brackets. Okay, now here's the thing. With the or, an or is a union symbol. I think we talked about that yesterday, did we not? Okay. So a union symbol is or. And now we go to the other side. I want to go from 8 to positive infinity. So that is the interval notation way of writing. X is less than negative 2 or greater than 8. And then, again, graphically, you don't have to draw the number line. I'm okay with you just doing this. There's negative 2. There's an 8. Use in parentheses because that's what our interval notation shows. So there's our answer graphically. All the numbers satisfying this inequality would be to the left of negative 2. Right. All right, what questions do you have for me? This seems pretty straightforward so far. Yeah? Hannah, got anything for me? All right. What's Kristen? You good? All right. So in this next one, when we have the less than, here we have an and problem now. And it doesn't set up any different, but it looks different in terms of its solution. So x's are now positive guts, x minus 3 less than 5. I'll just write the word and in here, but we don't need to actually keep that. Write our solution. And then now, negative guts, x minus 3 must be switch the sign and make the opposite value. And again, same concept. If I'm going to be less than 5, we're talking about 4, 3, 2, 1. And I think about numbers that are going to match that on the other side of the number line, negative 4, negative 3, negative 2, negative 1. That's why I'm going to the right of negative 5. Okay, so we add the 3 over, and we get x over. We get x is less than 8. Going to keep the and in here for just a second, and then adding the 3, we get x is greater than negative 2. Now, look at that and tell me what's wrong with that answer. How do I say I want you to express the inequalities? Right, small number left, big number right. So if we switch this order around, look at this, check it out. It should be x is greater than negative 2, and x is less than 8. Well, look at the inequality symbols now, right? They're kind of both pointing in the same direction. So in inequality notation, that's when you can just put the variable in the middle, and you do the less than 8 symbol. And then if you go like this, with a less than symbol and negative 2, what that means is x is greater than negative 2. When the variable is on the left, you read it less than points to the left, greater than points to the right. If the variable's on the right, you have to reverse that role. All right, so that's why we don't have to write the word and when we write this inequality for a less than or an and situation. We can just write it as an inequality notation or an interval notation. It would be -2 to 8. So I don't have to physically use the word and. So, or I definitely need to see it. In the and world, we do not. And then again, graphically speaking, -2 and 8, both of them are parentheses, and we come together right now over me. Concert T-shirt Tuesday. No one's wearing. Dang it. So those are the guys that come together, and they tell me the overlap. Less than 8s, greater than -2s, they only overlap between -2 and 8. What do you think about all this stuff? This is like life-changing, isn't it? What do you think, Alex? Is it life-changing? You're not very convincing, Alex. All right. Any questions so far? I know you're waiting for the application part of this. It's to come. Any questions, Christy? You okay with this? James? Taking any notes back there? Liar. Notebook's not open. Oh, come on. Really? If I were to go back there and open that, I'm not going to find any notes. Right? Well, you tell me I'm right.
No, you're incorrect.
Oh, okay. All right, moving on. Hey, what do you think we do differently when I got another number hanging out in the absolute value? Don't blurt it out. Don't blurt it out. I'm going to pick on somebody. Not literally like pick on them as in bullying them, but I'm going to actually choose them. Oh, okay. So, thinking about what do I do differently when I got this constant that's hanging out with the absolute value? And in 4. Oh, 3. All right, Mr. Booth.
Add 5 to both sides.
He is a brilliant man. We're going to add 5 to both sides because it's a constant, and I want to treat absolute value problems like just my linear or quadratics, where I try to get x's by themselves, right? Because that's what we're looking for. So you think of absolute values as getting what I want that bar, whatever's in those bars, I want to get that by itself before I do anything else. So I get the x plus 2 absolute value alone by moving the 5 to the right, and then I would be able to solve the problem from there. All right, before I let you go on that one here, let me talk real quickly about these next two, and then we can try a couple of them on your own. So that 5 gets kicked out. Now it becomes an 8. We're still okay, and then I set up my problems. Is this an and or an or? This is an and, because it says less than or equal to. Then I'd set it up that way and come up with 6 and -10. And then that's coming together between 6 and -10. All right. Let's take a peek at the, and I'm just going to, you guys, I'm going to start writing these things in interval notation, so just get used to seeing it this way. What's up, bro? All right, well, what about this next one here? Got this square root thing thinking, wait a second, there's no absolute value in this square root, so why are we even using the concepts of absolute value here? Anyone explain why this might be considered absolute value? See if we can get some people to think on this one. Got the square root of something being squared, and it has to be less than. Look at that, hands are flying everywhere. David, you put yours down for a second. Does that mean you're thinking still? Still going to go with it? Yeah. All right, we'll let you go. Help me understand, why am I going to make an absolute value problem out of the square root of x minus 3 squared less than 7?
Because when you square something,
he says, when you put a negative underneath something being squared, that negative will always become positive. And when you put a positive underneath something always being squared, it always becomes positive too, which means it sounds a lot like an absolute value problem. So the radicand, the thing underneath a radical, we treat like absolute value. So this is the same thing as me saying, and it's because we're squaring something that's being squared that we can do this. It's like the same thing as me saying the absolute value of x minus 3. Now that can be positive or negative. It has to be less than 7. It could be also a negative 7. Because if I was a negative 7 and I squared it, I'd still get a positive value that I can take the square root of. So that is why absolute values are what we would use or consider when we have situations like this. All right, and then that one can be solved. And or, what's that? What is that? What is it, people? Oh, good. A little more enthusiasm. Yeah. That's a little better, just like you almost got wrestled by something. So that's an and problem. Yeah, that's an and problem. We're going to set that one up. And then as our last one here, do I need to keep going on this one? Are you guys okay on the x minus 3 less than 7? Answers are going to be what? Can you tell that quickly? Can you see what the answer is going to be? Well, what would my interval be? What am I going to fill in here? Positive 10 and a negative 4, right? Yeah. What's up, Tanner?
Why is it absolute value?
All right, good question. It is absolute values because, think about this. Does it matter what I get in here for x minus 3 squared? Meaning, if that was a negative 2 squared, what would my answer be? Okay, I'm asking this. Let's say x minus 3 produced a negative 2. And I squared it. What would I get with negative 2 squared? Okay, now what if x minus 2 instead produced a positive 2? What do I get? Same thing. So this is like the part of the radicand, the thing underneath the radical, if it is being squared, that piece can be just treated like an absolute value because it can be positive or negative. Does that make sense? All right, now check this one out. This one's a little weird. Oh, sorry. Were you writing still? Were you writing? Yes, ma'am.
So does the negative don't have to be less than it?
Yes, when we write these intervals, you will always write them small number on the left, big number on the right. Good question. All right, so this one. Now I have, it's kind of like my and problem before, where I've got this interval, something hanging out in the middle is a variable, and then I've got these numbers on the right and the left, and everything points to the left inequality-wise. These, though, I need to be careful of. Need to be a little careful. Okay, let's treat this kind of like we did our very first inequality problem that we were talking about in section 3. Those absolute value bars weren't there. I just add 3 to both sides, and I come up with my answer for f. But we have these absolute value bars here. So I have to treat this as if I have, again, 2 separate problems. I have this one. I got the absolute value of x minus 3 greater than 0. And then I also have the absolute value of x minus 3 being less than 5. So we have 2 separate problems we're going to work out for this. And because it's set up this way, we are able to set it up like this. So x minus 3, I get rid of the bars because I now am talking about positive or negative guts. So we're going to be less than 5, greater than 0. And that's the positive gut part. And then we can also be x minus 3 is greater than negative 5, less. Now I don't have to put a negative in front of 0 because 0 is neither negative or less. So look at that. We switched it, right? Just like we did on the last one. We were talking about a non-absolute value problem. We've taken the two parts and we're solving them simultaneously. All right, then we just go for that x, just like we did before. If I need to add 3, okay, what's going on? Oh, that's if I have to add 3 to this side, because I need to add 3 to this side. Same thing's happening over here, right? Add 3, and now I get a 3 less than an x less than an 8. And over here, over here I get a negative 3. Oh yeah, thank you. Positive 3. Da-da, 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 da-da. How did I flip the signs? Good question. Why did we flip the signs? Okay, let's look at the red area here. Pull out the red chunk. So we look at the absolute values of x minus 3 less than. Like, let's just say we're talking about that problem. Right? When we look at that problem, we see an and. Right? And in this problem, it breaks down into x minus 3 less than 5 and x minus 3 greater than negative. Correct? So that is why we're breaking it into two separate parts. Does that help? Well, let's make sure we're clear on it before we keep going on. Were you all right when we did that back here? We did it right here.
Yeah.
And you understood why when we explained that if I'm going to be less than 5, I can be 4, 3, 2, 1, I can be negative 4, negative 3, negative 2. Okay. So we had to break it into the two pieces. We're doing the same thing here on this problem. The only thing that makes it different is it has this 0 is less than absolute value part of it as well. So we really have two separate problems that we're solving at the same time. Does that help explain?
That's one problem.
Yeah, but we're putting them together as one. We're writing them together as one. All right, so let's see what we get here. In the inequality notation, I have, this is saying I'm going to be between 3 and 8. Over there, what's the problem with that one, the way it's written right now? It's got to be switched, doesn't it? I have a big number on the left, small number on the right. So really what this becomes is that. And then in inequality world, it's going to be negative 2 to 3. Okay, but wait a second. Look at this. I've got that answer and I've got that answer. So how do we write them as a single solution? Because right now they're just two separate ones. Yes, ma'am.
Negative 2, 8.
Ah, you just want to go negative 2, 8. All right, let's take a look. That's a good thing. Is it negative 2, 8? That's a good question. What do you guys think? Can we write negative 2, 8? Thinking about all the numbers that would fit. It seems that this is okay, because look, I go from negative 2 to 3, and then I go from 3 to 8. There's one little hitch. What? Why is 3 not included? Okay. Going back up to the original, this little left symbol here, x minus 3 must be greater than 0. Can it be a 0? No, because it doesn't say or equal to 0. It says it just has to be greater than 0. So, if I were to accept that as my answer, that would mean that 3 is included. And 3 would not make this work because 3 would make it equal to 0. So, if that wasn't or equal to, then Nicole would be right. We could use negative 2. But it isn't a or equal to 0, so I can't. So then I have to use a union symbol between my two interval notations. I'm going to go from negative 2 to 3, and I'm going to union that with 3 to 8. And there's my solution. So you have to be careful of the ones that have a 0 on one side of my absolute values. All right, what questions do you have about that whole concept right there? If you don't like working them as a single problem as we've done here, then separate them into 4 different problems. Separate it into 0 less than x minus 3, 0 greater than x minus 3. And then x minus 3 less than 5, x minus 3 greater than negative 5. And work all 4 of them separately and then stick them back together. This is an AND problem. So here we have an AND problem using a union symbol, and that's only because I can't be equal to 3. So I have to make sure I indicate that I have a break with that problem. Wasn't that fascinating? That's fascinating. That's good stuff right there. All right, how are we doing? Fine. Okay, your turn. Your turn. Is that good, Taylor? Yeah, is that what you got? On number 2, we have an OR situation, so we're going to set up 2x minus 1 greater than or equal to 3. Have to write OR. And then 2x minus 1 less than or equal to 3. And then make it negative 3. So we have 2x is greater than or equal to 4, or x is greater than or equal to 2. 2x less than or equal to negative 2, x less than or equal to negative 1. And then we're going to put it as an inequality, which means from negative infinity to negative 1. And then I include negative 1, so I'm going to use a bracket. And then I'm going to union that with include the 2 and go to positive infinity. Number 3, we have an AND problem. So we're going to set it up 2x minus 1. I could do this one as 1. 2x minus 1 is less than 3, but it's also going to be greater than negative 3. And then move my 1 to both sides. So add 1 to both sides. Divide by 2. So there's the inequality notation, and the interval notation would be between 1 and 2. Negative 1. That's right. It's what a fast way. If it's an AND problem, it's faster. If it makes sense to you, do it. If not, go ahead and separate it into 2 different problems and the answers. All right, number 4. How are we doing so far? Yeah? Okay, at number 4, we got an OR, but we want to isolate absolute value things before we do any guts stuff. We want to get that 2 to the other side. So first of all, this would become the absolute value of x plus 9 is greater than 3. Now is when I start to separate it into the 2 problems. Not until then. Not until you have absolute values by themselves. There's no coefficient in front. There's no constant with it. I have it alone. Now I'm ready to separate it into 2 problems. This would be x greater than negative 6, or x less than negative 12. And if I'm thinking about inequality notation, from negative infinity to negative 12, union with negative 6 to positive infinity. So, 5, we have an AND, where I've got that 0. Got to be careful of the zeros. So we separate this. It's ready to be broken into 2. have x plus 4 is less than 9 and greater than 0. But we also have x plus 4 is greater than negative 9, less than 0. Solving it simultaneously, we have negative 4 less than x, less than a 5. So that's negative 4 to 5 for that interval. And here we have a negative 4 and an x and a negative 13. But it's written the wrong way. We want to switch it up. Small number on the left, big number on the right. Switch the direction of the inequalities. Negative 13 to negative 4. So now we have to stick them together. The inequality of negative 13 to negative 4 is a smaller value of numbers than the negative 4 to negative 5, and so it looks like this. Union with negative 4 to 5. And again, if that had been or equal to 0, then I just could have gone from negative 13 to 5.
But I can't do this. Yes, you want to do it the other way, negative 4, 5.
Yes, because think of a number line. We always do small number left, big number left. So, how are we doing so far? Yep.
Or did you do?
No, we can't do negative infinity to infinity because look, we've got a gap, right? Between negative 12 and negative 6, there are some numbers there that cannot be included in this inequality. Good question, though. All right, and then our last one, we say these absolute values of a squared radicand become the same thing as the square roots of the squared radicand become the same thing as an absolute value problem. And we end up with an x plus a 6 less than a 10, but also greater than a negative 10. Moving our negative 6 around. We end up with that. All right, who was 3 for 3? Any 3 for 3? Ooh, nice. Yes, sir. Oh, no, that's just how it is. Nothing new there, just always something going in the mouth. We good?